So this is page 490, example 2. Try this part. So let's first draw the right triangle. And this is angle alpha. And it says alpha is angle opposite the side of the length 4. So the side of length 4 opposite this angle alpha. So this length is the 4. And then we have the another leg of length 2. So which is adjacent, right? So this is 2. So now let's first get the length of the hypotenuse r. So by the Pythagorean theorem, we know r squared is equal to the sum of the square of the next two legs, right? So you have the 2 square and plus the 4 square. Then this just implies you have the r squared equal to 4 plus 16, and then you get 20, right? And 20 is equal to 4 times 5, and this is equal to 2 square times 5, right? Now you take the square root of the r square, you get the r equal to the square root of the 2 square times 5, and then you take this 2 out, so you have the 2 times the root of 5. So after we find r, then by the definition, sine alpha, which is equal to opposite over the hypotenuse. So actually this is just the hypotenuse, right? So now it's equal to 4 over the 2 times root of 5. And then we cancel this 2, we get the 2 over root of 5. And we multiply both the numerator and denominator by root of 5 to rationalize this denominator. Then we get 2 times root of 5 over 5. So this is the sine alpha of this acute angle in this right triangle. Now the cosine alpha, which is equal to adjacent over the hypotenuse, right? So adjacent is equal to 2. So hypotenuse 2 times root of 5, and this to cancel. So you have the 1 over root of 5, and you rationalize the root of 5, then you get the root of 5 over 5. So this is the cosine alpha. And then tangent alpha equal to what? In terms of the adjacent, opposite, and the hypotenuse, tangent alpha equal to what? 4 over 2, right? The opposite over the adjacent. So you have the opposite over adjacent, and the opposite is the 4, adjacent is 2. So tangent alpha is equal to 2. So we just have seen such a simple example in which we know the 2 legs, and we try to find the sine alpha, cosine alpha, and tangent alpha. So now let's talk about solving a right triangle. So finding all the unknown lengths of the sides or the measures of the angles is called the solving a right triangle. Okay, so just finding all of the unknown length of sides of the measures of the angles. It's called the solving a right triangle. And you can see some measures of the length of the sides are absolutely necessary to solve a right triangle. If you only know the measures of angles, you may have the infinitely many triangles with the same measures of angles. For example, say we may have such a 30, 60, and 90 degree triangle. And then you may also have this triangle with the same measure of the angles, right? So you may have the infinitely many right triangle with the same measure of the angles if you don't know some length of the sides. So that means to solve a right triangle, the length of the sides, okay, are absolutely necessary. Now let's look at the one example. Let's look at the page 491. For page 491, example 3, try this part. So in this right triangle, we know one angle alpha, 60 degrees, and we know the length of the C. C is the length of the hypotenuse. And then we need to solve this right triangle. Okay. Now let's come back to the whiteboard.